Hello, parents and teachers who may be watching. Welcome to Creating Math Ahas for Parents. Thanks so much for choosing this video. Now, I'm Dr. Sandy Atkins, Sandy, and you may be wondering to yourselves, why in the world are there 3D shapes when we're going to be thinking about 2D geometry for children? And I hope to explain that to you as we go through the video. Now, hopefully, you've gotten a chance to watch the 3D Geometry Fun for Children, and in that I explain how a child's world is full of 3D shapes. That 2D shapes are really a mind's eye idea because 2 dimensions have no thickness, right? We have length and width, but no thickness. In this video, I want to show you some things you can do with your children or things that your children may be experiencing in school to help them understand about 2-dimensional shapes. So we're going to be using these 3D shapes to do that. I'm just going to clear them away for a second. I'm going to bring back some dough. This is whether you have Play-Doh, salt dough, some type of a dough that your children or clay that they can model with. One of the things we'll do to introduce your child to 2D shape is think about them as the footprints of 3D shape. So I could take a block, these are simple table blocks that I've had for years, and they just make the impression in the shape. They make the footprint. Now, you may see your child doing this with sponges or with paint to make actual paper designs where they're going around and they're making those actual designs in it. They may do footprints of cones. They may actually just explore and start to do the imprint of the apex of a cone, the vertex of a cone, or the apex of a pyramid, and you might start to see an inverted cone or an inverted pyramid. And so at first, we just have your children explore, but we want them to look at footprints. And then once they have the footprints, we can start to think about, well, what do we name the shapes? And then how in the world do you do a footprint of something like a cylinder? Now, if you think about cylinder, and we're going to come back to cylinder in a little bit, right? The footprints of the cylinder happens to consist of the 2 circles, right? We have the 2 circular shapes, and then you take this and you roll it. See, a cylinder is that rectangle, right? It has a rectangle that's been folded up on itself and then has the 2 circular bases. Now, see, this becomes important as we get into surface area to understand that, and we'll look at that in a bit more too. Now, I'm going to trade out, and I want to think about surface area and ideas about that. Now, your children might be in school getting something called a net. And in the net, what happens is your children are given a 2D representation of a 3D shape. Essentially, what they're asked to do is identify the shape they would get if they cut this out and folded it up. Now, for many of your children, they haven't necessarily had experience that helps them go from the 3D to the 2D, but then they get this one, and it's hard for some of the kids. But see, think about, we're going to go back to the dough, but this time when I make the footprints, I have that base, and without picking it up, I'm going to tilt it over and make that footprint. I'm going to tilt it back and make one here. I'm going to make one back this way. I'm going to make one this way. Does that now look familiar? Can you see in that impression, hopefully, yeah? You can see in those footprints this shape. What shape did I use? A pyramid, square base. I can make those imprints. Now, why we want to think about nets is back to surface area. You see, what is the surface area of this pyramid? How do I find it? Well, I find the area of each of its faces. So it helps children very early on to understand and think about 2D shapes as footprints of 3D. But as they go up through the grades and they start thinking about surface area, it helps them envision the actual, what the shapes of those faces are, how they come into being too. So have some fun with your kids. If you have blocks of different kinds, just let them start to do those imprints. They could make designs with finger paint or paints onto shapes and see those 2D shapes come out from the imprints. They could make designs into some type of a clay or a Play-Doh or wet sand, and they can start to look at the shapes and name them. Now, one caution, as you're working with your children and naming them, it's really not the children naming the shapes, right? As you're working with your children and naming the shapes, you want to make sure that we are very precise. And I want us to think about 2 dimensions have no thickness, as I said. So it's important that we don't use a word like thick and thin, words like thick and thin, when we're talking about 2D shapes. So having that bird's eye view, these look like circle type shapes, but quite often I'll hear kids talk about thick circles and thin circles. Circles, that's a 2D shape name. There is no thickness. These are cylinders. You can have a thick and thin cylinder, but not a thick and thin circle. Same thing here. Thick and thin rectangle. No such thing, right? Rectangles are 2D shapes. Triangles, no thick or thin triangle, 2D shapes. So these are all prisms. There are thickness to them. So we want to make sure that we begin early with your children understanding what is a 2-dimensional attribute, right? Length and width. What are those? We can look at how long and wide, but we aren't necessarily going to talk about, or we aren't going to talk about a thickness, a 3-dimensional attribute. Now, once your children get comfortable with this, see as they progress up, they start to look at the characteristics of the 2-dimensional shapes. Here's a parallelogram. I can start to look at the line segments, the sides of the parallelogram being parallel, being congruent, the same length. Opposite sides are congruent. Opposite angles are congruent in parallelograms, which means the footprint of this one, opposite sides are parallel, opposite angles are congruent. This happens to be the footprint, a special parallelogram we called a rectangle, an oblong. And as we go into the square, it's a special rectangle, one with equal sides. So your children will start to experience a bit more of the characteristics, and that's where measurement comes into play. And I'll put the link to the measurement and using a protractor. I'll put that link in the description below. But see, think about also triangles. And they'll be starting to think about triangles and identifying triangles based on characteristics. Now here, this is a right triangle. It might not look like a right triangle the way the orientation is, but do you see the right angle at the top? It's really important that your children learn that orientation doesn't determine if this is a right triangle, that I could turn it any way I need to until I actually have that right angle. But this is a right triangle whether it's sitting on a base, there, or here. And so we're wanting to make sure your children have enough experiences early on to, again, think of 2D shapes like footprints, start to look at characteristics of 2-dimensional shapes, use that idea to be able to think about surface area like we looked at here, understanding that that footprint that, again, your pre-K or kindergarten child may be doing will lead to some more advanced geometry that they'll need as they go up through the grades. Now, I hope you found this video helpful. If so, please consider giving it a thumbs up. Subscribe to the channel so you know when other videos are available. Share with others who might find this useful. Click on the notifications bell when you know, so you'll know when other videos become available. Again, I really appreciate that you chose this video for watching, and I look forward to seeing you in future videos. Thanks so much for watching.